All right, hello and welcome to everybody who's getting joined in. We went ahead and started a few seconds early here just to give everybody a chance to get from the waiting side to the joined side. And it looks like we are at that point now. So I'm going to go ahead and get us started here and say thank you for joining us. Welcome to this quick conversation about advanced ice technologies. And really, it's a lot of technologies that you're already familiar with. It's really just bringing the story home in the case that's being made that vehicles today are far different than what they were in the past, and the opportunities for a lot of diagnostic repairs and diagnostic work is going to be out there. And here's the thing, we have the technologies within our categories, which means you have everything that the customers are going to need when these newer vehicles come in with all these new technologies. So that's really the conversation today, is putting that all together and trying to bring that mindset of, hey, the days of the tune-up are long gone. Even the typical tune-up we know now of an oil change, maybe a cabin air filter and things like that, those are including even more things at this point. So with ICE technologies changing and advancing, we're going to have a lot of opportunities. But before we get started with that, though, don't forget, if you have an opportunity right now, pull out your cell phone, take a picture of this, or go ahead and scan the QR code. That's going to get you to the registration site for the upcoming calls for the rest of the year. You see today is ICE Technologies. Next month will be ignition coils, and then so on and so forth. And so if you can't register at this very moment, that's okay. You see there's the link there that you can type into your browser, and that will take you to the registration site as well. So just don't forget, we do have more calls coming up for the rest of the year here. So again, talking about advanced ice technologies, let's talk about why it matters. And we'll use one perfect example of why understanding how many more technologies are in vehicles today matter. So if we even just go back to 2005, 20 years ago, the most popular selling platform out there, the F-150, you had three options. You had a V6, you had two V8s. One of those V8s had VVT. The V6 and the other V8 were still single overhead cam, and they both used multi-port fuel injection. The reason I call out that one V8 using VVT is that's really the first time Ford got pretty heavy into, in some ways, testing VVT and using it as a guinea pig on this one because it produced a lot of issues, and it was perfected over the years. But the 5.4 liter V8 VVT system made a lot of people a lot of money, and it was pretty nice. But that was 20 years ago, and we were really first getting into those types of repairs. Well, if we fast forward even 15 years to the 2020 year model, that same platform, the F-150, went from three options to six options, where we ended up having four V6 options, one V8 option, and even a 3-liter Power Stroke diesel option. But the point I want to bring up here is, if we go back to '05, we had three options, only one with VVT, and they all had multi-port fuel injection. Well, if we look at these new six options, we have four that have at least one turbo, three that have two. We have two that don't have a turbo. We also have all six using a VVT style system. We also have some using just gasoline direct injection and some using gasoline direct injection and multi-port fuel injection, and then one there with common rail because it's a diesel. So the point here is, some of the conversation we're having today is around several of these components: GDI, MFI, VVT, those kind of things. This would be considered an advanced ICE technology, putting things together and using them for the benefit of several key points. And what are those key points? It is that manufacturers have to do three things. They have to improve fuel economy, they have to reduce emissions, and they need to do that while improving both the performance of smaller, lighter engines, but also maintaining the performance customers, are expecting from the vehicles that they purchase. So they have to try to get more fuel economy out of it. They got to try to not, make as many emissions, but they got to give you your power. It's kind of hard to do unless you put a lot of things together to make it work. And that's what they've done with all of these advanced ICE technologies going into one platform and pretty much every single car that's coming out now. So what are some of those technologies? This is just a handful of them, but turbocharging, electric vapor canister purge pumps, obviously the VVT systems, GDI and MFI systems together. We'll talk about that. The newer platforms out there, some of them will have some of these cylinder deactivation solenoids and so on and so forth. So they're really putting together a lot of different technologies to accomplish those three goals: improving fuel economy, reducing emissions, and keeping that performance or improving performance for the end user, the driver. So we'll start by talking about turbocharging. So I don't know if you saw our most recent Power Hour, but if you go back and watch that, you'll see me talk about the point, which is in 2010, only about 10% of vehicles being made had a turbocharger on them. Well, if you fast forward to today, about 50% of all vehicles coming off the assembly line now have at least one turbocharger. And the reason they're doing that is, again, they've got to come up with all these goals: fuel economy, power, all those things. Well, by turbocharging the vehicle, it lets them use a smaller engine, but also gain fuel economy and produce less emissions because they can get that horsepower and torque of a larger engine with that turbocharger, but in a very much smaller displacement platform, right? So that's why you see so many vehicles, especially 4 and 6 cylinders, coming with turbochargers now. We're able to get that power, but we're also able to maintain a better fuel economy and emission standard. Now, here's the thing about turbochargers: they almost never fail on their own. Almost always, when a turbocharger fails, it's going to have something to do with the oil, unless something was ingested through the intake. So, say maybe someone used a cheap air filter and the medium fell apart and came through and the turbo ingested it. Obviously, that can have a profound impact, but usually it's an oiling problem or a clogged line. So, our suggestion here is always, whether it's a DIY customer or that technician that's replacing a turbocharger, let's hope and let's ask and see if they found the root cause of the failure. Was it the fact that the oil change wasn't done on time, which is pretty common, or was it that a line was clogged somewhere that was starving the turbo of the lubrication it needed? We need to know what that root cause was. But remember, we also need to recommend those service related parts for when a turbocharger is replaced. Obviously, a new air filter needs to breathe. We need new oil and an oil filter so that it's lubricated properly. And in some cases, some of these turbos are coolant bypass. They're actually cooled with the coolant as well. So you may need some of that. But here's the thing about turbocharging and some of the other categories we have in these advanced ICE technologies: the reality is people don't do their maintenance on time. So we're going to have a lot of opportunities for, again, diagnosis and repairs when it comes to turbochargers. So, it's on us to really recommend those related components whenever you do, go to sell one. And the nice thing about our turbocharging program is we've got a lot of those hard to find that are just a couple days away, maybe even a day away in some cases on the drop ship program. So we've got them covered on turbocharging because that is one of the most common new, advanced ICE technologies you're going to find on vehicles. The nice thing, again, is an all new no core turbocharger kit. So they don't have to worry about keeping up with cores. We also are going to get what we need in the box. It's going to be a complete program in the box. So, here in Irving, Texas, we do the testing on all these turbos. And if it's in the box, it's because we've identified that you really need to replace this whenever you do this turbo job. So a good perfect example of that would be the 1.4 liter Ecotech here you see on the screen. Now, these were a very common issue turbo in the very beginning for this platform, mostly because of that line that you see the little red arrow running to. That line, the original design, was poor. It would allow clogging, and it would starve the turbo of oil, and it wouldn't lubricate, and the turbo would burn out rather quickly. Well, luckily, the OE did update the design of that hose, so the hose needs to be replaced when the turbo's replaced. Well, when you order one of our kits, that means you're going to get that updated line in the box along with everything else you need, including the turbo, the new studs, seals, band clamps, and all that kind of thing. So, with the increase in amount of vehicles coming through the shops with turbo related repairs, your customers can now know that if they order one of your kits, again, it's all new, no core, but it's going to have everything in the box that they need to do the job right the first time. And if there's an ancillary component, say they need a turbo drain or a map sensor or a wastegate solenoid or an intercooler, if there's another component that's required that they need because something else is, broken, or maybe it was in a collision or something like that, we have those components as well. So it's not just the turbocharger in the box, it's all those secondary components that the customer may need as well those are available to them in the program. And these are tested again very heavily, not just on stand, not on bench testing, not just hot gas stand testing. Again, we're putting these on real vehicles and putting thousands of miles on them before they ever make it into your box, onto the shelf, and ready for the customer to purchase and put on a vehicle. So that's just one category, turbocharging. But remember, we also have vapor canisters in almost all these cars now. These vapor canisters that sit near the back, and they're supposed to trap those vapors when you're getting fuel, and the vapors coming from the fuel tank keep those from being emitted. Well, we have to purge those periodically. That canister can't just stay full. And when we have these vehicles with these turbochargers now, it's hard to build enough vacuum to get that vapor canister purged the way that it normally would under a vacuum operated system. So in these cases, we're going to be including electric vapor canister purge pumps. And what that's going to do is, instead of relying on vacuum, it's going to be able to turn off and on to purge those vapors and keep that canister working properly. Biggest reason these fail, same thing with the canister, is topping off of the fuel. Got to be careful. I know it's a OCD thing to want to get to that 0 on the amount of money you spend on gas, but topping off can actually cause thousands of dollars of damage on things like these pumps and the canister. So we need to be careful with that. And unlike a vacuum operated system, these types of systems also make it a little bit easier for the technician to do a diagnostic, because they can be commanded on and off through bidirectional controls, and they can verify that it's working properly before they ever go and tear anything apart. And just to give you an example of how often you may have an opportunity to sell one of these, just one part number here covers 2.8 million GM vehicles in operation today. So a lot of opportunities coming, and there's even more with other manufacturers along the way here. All right, so let's take that and let's couple variable valve timing with it. Now, remember what I said, one of the biggest things we have going for us is most customers do not do their maintenance on time. So same thing with turbochargers. One of the other categories that can get taken out rather quickly is variable valve timing. It's important that oil changes are done and good clean oil can get through these, because what VVT does is it adjusts the timing in real time depending on how the driver is driving the vehicle, and that's going to help them either maintain performance or reduce performance when it's not needed. And in those times when it's doing that, it's reducing those NOx emissions as well. So it's important that VVT works properly. And the most common version of VVT still on the road today is oil driven. It's oil actuated. So just like with turbochargers, VVT normally doesn't go out on its own. What usually takes it out is lack of oil maintenance, or no oil at all, right? And there was some also poor OE designs in the market when VVT really started hitting big, especially on GM. But for the most part, it's going to be oiling issues. So it's really important to make sure that the oil levels are correct at all times. The correct weight and specification is being used. So if it says 016, you need to use 016. That specific solenoid is designed for 016. And if you try to put a 520 or a 530 or whatever other version through there, that oil may not be able to get through the screens on that solenoid properly and actually phase the phaser. So correct levels, correct type and weight, and at all times. That's the most important thing we can tell you about variable valve timing. And again, your customers already know that. The technicians already know that. It's just a matter of kind of, again, piecing it together and saying, hey, we've got a lot of vehicles with a lot of new technologies on them. And really, the funniest thing is the same thing is killing all these things as what was killing motors for many, many years before that, which is poor maintenance. All right, so now we put that together. Now let's talk about fueling. We're talking about air coming in. We're talking about lubrication. Let's talk about the actual fueling. So again, remember I said we have some that have GDI. We have some that have multi-port fuel injection. Well, now we also have some that are incorporating both GDI and MFI on the same vehicle. So you may even have an opportunity to have up to 16 fuel injectors need to be replaced at the same time. And the reason they're doing this is that multi-port fuel injection has been around for a long time. They've kind of perfected that, but GDI was developed many years ago, and it was really kind of nice because it was really good at lower speeds and it optimized performance and efficiency at the same time. The problem with GDI is one, it's really geared for that type of efficiency, but two, it carbons up really bad. The tips of them get carbon buildup really quickly, and it causes them to have a bad spray pattern or flow rate. And that's not good for, our air to fuel ratio. So what they found is if they use multi-port fuel injection, it would be really good at startups and higher speeds whenever we're commanding more quickly. But then GDI at lower speeds would again optimize that performance and efficiency. And if we would use them together, while the multi-port fuel injection is working, it's actually spraying the tips of those GDI injectors and cleaning them at the same time. So it really works together hand in hand to optimize efficiency, less emissions, more power when needed, and keeps the system clean. So it's actually kind of a cool system. And it fails just like all the other, fuel injectors in the past have failed. Electrical failures are going to be one of the biggest reasons, but also contaminated fuel and worn seals. So just keep that in mind. You may see systems with two different types of fueling in there. It's not a mistake. They're actually doing that, that now. And if it does come down to a GDI or MFI system, depending on whatever the customer needs, we're going to have everything in the system that they may have to have that's going to be required. So in case of a GDI, if they're going to do a pump, if they just need the pump, we have that. If they need the full kit, we have that as well. If they need feed lines, if they need pressure sensors, camshaft followers, we have that within the lineup. The one thing I will mention is, though, with some of the Toyota GDI injectors, they do have reference numbers. This is on GDI. Make sure the customer looks at that before ordering the wrong ones, because that could indicate a different fuel flow rate than the other injectors in the system. And again, we have everything the customers need. Nobody holds a candle to us as far as count and coverage goes. 762 multi-port fuel injectors, 193 gasoline direct injectors, and those are all brand new, never remanufactured. Nobody else can say that about their program, which means there's nobody out there that can go and talk to your customers about a better program than what you have available to you. All right, so there's some of the fueling. Well, what about reducing power when we really don't even have anything to do with it? Well, now we're seeing that as another advanced ICE technology with cylinder deactivation solenoids. And what these do is they improve that fuel economy on the larger engines like a V8 by deactivating some of the cylinders at cruising speeds. So let's say we're, doing 75, 80 on the highway. Obviously, we're using all 8 cylinders, but then we exit the highway. Now we're coming down to a slow cruise, and then we're going to get on a surface street, and we're not going to exceed more than 40 miles an hour. Well, as our drive cycle changes and the conditions change, PCM is going to be watching, and it's going to go, hey, we don't need all these cylinders right now. Let's kick it back to 6. That's what the deactivation solenoid does. It just reduces the amount of active firing cylinders. So again, that you get better fuel economy, you reduce the emissions, and you don't really lose power, because the minute you hit the gas, that solenoid kicks back off, and now we've got all 8 cylinders again. So it's kind of a cool technology. It's definitely on the rise. It's not huge or widely adopted, but there are some manufacturers out there that are using it, like your Jeeps, Chryslers, Rams, Chevy, and GMC. We have your customers covered on those deactivation solenoids. So, regardless of which advanced ICE technology it is, we're working our best to make sure that the category of that type of technology is covered for your customer. And the same thing holds true with electric vacuum pumps. We didn't, again, used to have to worry about that as much, but again, on these smaller displacement engines, especially those with turbochargers, it's hard to build enough vacuum for braking performance. So we're seeing a lot of cars adopting electric vacuum pumps as well, just like the electric purge pumps, right? And these are going to fail the same way. Moisture contamination or moisture intrusion, any type of overheating or constant use. So if you've got a vacuum leak and this pump is having to run at all times, it's going to wear it out quicker. And obviously, that's going to cause an electrical motor failure as well. So again, these are not as widely adopted, just like the cylinder deactivation solenoids, but there are 12 part numbers already to cover the most common out there with them. Again, Chrysler, Jeep, Ram, GM, Volvo, and Ford. We've got those vacuum pumps, those electric vacuum pumps ready for them. Another advanced ICE technology that we've seen adopted pretty widely, it's kind of a quiet one. It just happened, and you don't really think about it, but active grill shutters. Now, if you've ever seen, like a Talladega or a Daytona race, when they go to qualify, they tape up the front of the grill. so they get all that perfect aerodynamic, all the air over the top of the vehicle. That's definitely going to make the engine run a little bit hot, and it definitely takes a lot more fuel. So it's not very, you know, fuel economical in any way. But they're only going to run it like that for 2 laps, and then they'll take the tape off when it's time to go for the long race. Well, it's essentially what these active grill shutters do. They open and close like louvers. And, whenever they're open, it's going to let the, airflow over the radiator and the condenser cool things down. And then when it's closed, it's going to shut that off and allow the air to flow over the vehicle, improving efficiency. So with the active grill shutters, we're actually being able to, and, again, going down the highway, something like that, everything seems good as far as temperatures go. Maybe we close these up and get a little bit more efficiency and less drag on the front of the vehicle. But then things warm up, we open that grill shutter back open, and we get a little bit more cooling over the radiator and the condenser. Kind of a cool technology, and working again hand in hand with all these other ICE technologies to give you better fuel economy and keep that performance out there as well. And going along with a theme here, electrical AC compressors. Now, these, just like the grill shutters and some other things, are going to be found not just on ICE engines, you can find them on EVs and hybrids as well. But the electrical AC compressors definitely improve that fuel economy by, it basically pulls the strain away because there's no belt. There's no belt driven compressor on there. It's turned on and it's turned off electrically. So it can be commanded at any point in time, and it'll be a way more efficient system than the actual RPMs of the motor. And of course, just like, any compressor, they can, leak or seize due to oil starvation. But on the electric motor side, you can also have the motor fail over time. But this is something that's being pretty widely adopted at this point, and it's going to be adopted even more because, again, it's more economical, and it's going to help most of these manufacturers get closer and closer to these CAFE standards that everybody's asking about and holding people's feet to the fire on. So again, remember, these can be turned and operated at any time, but the other things that's important to mention when it comes to electrical AC compressors is if you are selling one, whether it's to a DIY customer or a technician that's doing a professional job in the shop, make sure we sell them the correct uh, compressor oil. It's a non-conductive AC oil, and it has to be used on these so that you don't have a short to ground. Typically, if you get one of ours, obviously you open the box, it's going to tell you exactly which oil needs to be used. And then, of course, if you get one of the actual kits, it's all good to go. So with that, I'm going to pass it over to Mr. Aaron Shaver in Marketing Services to talk about some of the things that have been put together to wrap all these conversation points I just made up and go in and talk to a technician about it, hopefully starting today. Go ahead, Aaron.
Yeah, awesome. Yeah, thank you very much, Corey. That was great. So yeah, Corey covered really 8 different modern systems that we're seeing on later model vehicles. There's certainly going to be more as time goes on, but to help you in the field spread these messages, show service providers that you understand this technology and that you have components to address this technology and so many of the OE failures that we're seeing. We've created several different marketing pieces. We have these what's in your box pieces that are really simple program overview, two-sided brochures. We have just the facts brochures that speak to specific parts and some features and benefits around them, as well as a newer template that we created last year for advanced technology solutions, where we speak to some of the more recent vehicle technologies that we've started to see. So you can go to the street with this and talk to your service provider customers and let them know that you have these parts. Then, additionally, we also try to support you digitally. We have the BWD YouTube channel that has over 500 technical and installation videos, as well as specific playlists for a lot of these advanced ICE categories. And then, just to bring it on home, folks thought that we would be seeing more and more and more electric vehicles. Adoption has slowed. But what we are seeing is that gas vehicles, ICE vehicles, are becoming increasingly electric themselves. So you are seeing things like electrical compressors, electric vacuum pumps. We suspect these trends are going to continue as it's a good way for automakers to improve fuel mileage. So, even though the vehicles are still gas, they're much, much different than they were, just a few years ago. What you have from us at BWD is a genuine commitment to continue developing parts for these latest technologies, and something that sets us apart from some of the other folks out there is that we are a manufacturer. We do have our own design and manufacturing capabilities with plants all over the world. Within those plants, we do a lot of our own lab testing for durability. We do end of line testing on parts before they're put in the box. And on new components, we also do on vehicle validation at our vehicle testing center in Texas. And that's something that's pretty unique to us, but very, very helpful in the R&D process. And just a good way to know that the parts will actually perform correctly and integrate with these modern electronic systems. In addition to offering the turbochargers and other components, we also have all of the related parts that are required for a complete service within these categories. And then, as we just went over, um, we create the marketing and sales support materials to help you, to help everyone on the counter, and to spread the message to all of your service provider customers. So, yeah, thank you very much for listening, and we hope you have a great day.
And thank you, Aaron. I appreciate you wrapping us up there. And once again, thanks to everybody for joining us today. And we hope to see you next month when we talk about ignition coils. Have a great day, everyone. We'll see you next month.